I once saw the Typhoon, which is the fighter aircraft, saw the helmet for the Typhoon. It's what the pilot wears. It's a $2 million helmet. And when that
$2 million helmet.
Yeah, heads-up display, video, audio, augmented reality built in. And when you eject, the harness on that helmet must blow before the ejection. So when the pilot ejects, which can happen often, hopefully not, that mating into the aircraft must disengage.
Hi, my name is Robert Schmidt. I'm Deloitte's Chief IoT Technologist, also known as Mr. IoT. My deep passion is all things digital. And today on my show, Coffee with Mr. IoT, I have Ajit Gokhale. Gokhale.
Gokhale. Thank you.
Thank you for practicing with me. Ajit, we're doing this for the second time today.
Yes.
You are National Instruments SVP and GM for portfolio business.
Yeah.
And we today, this morning, had already done a show together, the keynote, and now it's a turnaround. I get to ask you questions, and I can just sit here and enjoy your answers. Thank you for being here.
That's great.
So, Ajit, what does portfolio products mean? Does that basically mean you got the products nobody else has?
Yeah, so portfolio industries is the set of industries. We have 4 business units. Those 4 businesses have industries. One of them is semiconductor, one of them is transportation, so that's cars and trains. The other one is aerospace, government, defense. And the 4th is all the other industries. And in that collection of industries, let's say 9 or 10 big industries, there are 4 or 5 that are bigger. History of National Instruments, we have a lot of customer loyalty and footprint and validation production, and that's electrical machinery. You can think of a pump or a rotating machine. Consumer electronics, these devices, set-top boxes, TVs. And then energy, so oil and gas, downhole drilling, fracking, and then academic, so all the universities of the world. And even things like life sciences where our products are used in production. So I actually have 100% ownership with all the customers who are in those industries. And then all the BUs share the products. So we all share LabVIEW. We all share the data acquisition products. But the BUs are add up to represent all the revenue of National Instruments.
That's a really wide portfolio of products.
Yeah, portfolio of industries.
Yes. Wow, but I'm impressed. That's like you got to go deep in many different industries.
That's true.
Sort of like, is one of the industries one you originally came from or spent more time in?
Yeah,
or?
it's funny. I'm real excited to be in this portfolio. I picked it, and not that I would get my pick, but they asked, and I said, man, I think it's really cool. But it's funny, the last 3-4 years, all of my visits have been with semiconductor customers, automotive customers, and then my background has actually been with a lot with aerospace, government, and defense customers. Now, the one industry I have visited a lot over the last 29 years is academic accounts. So I have a pretty good understanding of them. But we do a lot of business not only in academic, but in electrical machinery, energy, and consumer electronics. And those are big industries for me. So I picked the one that I thought I would be most interested with. And we will focus. We will focus in areas that we think can get growth, like we spoke about this morning.
So you spend a lot of time in a variety. You picked portfolio because it's wide.
And it was interesting to me,
I get it. 5G.
Yeah.
Is that part of your portfolio?
It is. 5G is a great technology. It is incorporated into many devices.
Do we get 5G today? I mean, are you using 5G yet?
My phone in the top right says 5G. I'm not actually convinced that it enables some of the connectivity of 5G. The consumer device, our phone, that's one of our products. We have customers who make those kind of products, either modules or really the entire device. But it'll show up in streaming devices. It'll probably show up one day in our fridge and washing machine as the follow-on to 4G. but it'll show up in many, many different devices. Your Nest little home automation unit, it'll show up in many, many different places. So yes, I have customers who will integrate 5G into their devices.
With what you do at National Instruments, maybe it's worth just tell us a
Yeah.
little bit. What is National Instruments? What's your
Oh, good question. Good
what do
question.
you
So National Instruments is a measurement company, and what are we known for in the industry and by customers? We're known for software. We're very good at writing software, different levels of software, the software that a customer would use for a development environment. And then the key part is, you can think of really simple software like a printer. That's really simple printer drivers. But when you have measurements and you want to make those measurements, the hardware that you plug into a PC-based environment, modular PC-based environment, has a lot of drivers, and they have to interoperate. They have to move data very fast. 5G generates a lot of data.
Mm-hmm.
And then you might have to synchronize multiple measurements. You can imagine a device like your little phone here. You got audio, you got video, you got 5G. You might need to synchronize some of these things to make sure the audio and the video line up. And so our customers know us for software that can make measurements from different devices, different physical phenomena, 5G being a communications phenomena, and then taking that data and doing math to it. So we talk about this thing called acquire, analyze, and present. It sounds easy. Acquire anything, analyze it, data analytics, signal processing, then present. You can present on your display, you can send it to the web, you can print reports, all kinds of different things. So,
And when you say develop, this is typically hard development on the machine. This is firmware. This is stuff that actually resides inside the machine. It's not the web development that we think of. It's
That's-
really true hardcore hardware firmware development, right?
it's that development software is done by us. It sits on our devices. The customer programs at a much higher level.
Yeah.
They program at a level where they can wire together graphical blocks, quickly make a measurement. So you'll have like a PhD in mechanical engineering. They're an expert in their domain. They have a measurement problem. They want to quickly capture some data and do some pretty serious signal processing on it. They don't have to have a PhD or a master's in computer science to do that, though we have those users too. And they can quickly use our tools to make some measurements and really automate those measurements. That's our expertise, is in automation of measurements and test.
So with your company, what
Yeah.
you get to see often is the stuff, everything before we get to see it, right?
That's right.
You get to see the product development
Yeah.
of an Intel or some
Oh,
other chip makers.
Yeah.
And so what's
Absolutely.
the new stuff you're looking forward the most to?
Oh wow! Well,
The stuff I haven't seen yet without
I
mentioning
got to
names.
tell you maybe what I've seen in the past, and then I'll tell you what I'm seeing now without maybe divulging any
Sure.
customer confidentiality. But I once saw the Typhoon, which is the fighter aircraft, saw the helmet for the Typhoon. It's what the pilot wears. It's a $2 million helmet. And when that
$2
helmet,
million helmet.
yeah, heads-up display, video, audio, augmented reality built in. And when you eject, the harness on that helmet must blow before the ejection. So when the pilot ejects, which can happen often, hopefully not, that mating into the aircraft must disengage, and it must be a foolproof system. So testing that interface, I went to the cockpit, I saw them making the helmet and the harness and testing it with the Typhoon fighter. I've been into open heart surgery before, where they had a machine hooked up to the heart under open heart surgery, doing pressure and volume inside the heart. And then they were looking at our products tacked off that heart-lung machine, so that machine was really doing the monitoring. I've been down in the Large Hadron Collider in 2004, about 10, 15 years before they found the Higgs boson. Most recently, I think I get a little bit insight into some of the future devices that are coming out, either on our hand or that we might use, and some of the cool new technologies that are being integrated. You've probably read a lot about VCSELs and rendering technology and how they might integrate into future consumer devices we have, and holograms and video conferencing, how it could change. So I see that. I see some really cool things in research labs at universities, things that are just ideas in really, really good PhDs' heads around communications and smart cars and electric vehicles and things they're trying out. Yeah.
That's very cool.
Yeah, it's cool.
So one of the things, I'll bring this a little bit back to what
Yeah.
we've done together with between Turnkey IT, National Instruments.
Yeah.
And one of the things Ian Fountain, who most of my interactions were with, we always talked about the lick and stick puck, the wireless sensors that you're developing. Where are we on this? One of the things I find difficult when I go to new clients is instrumenting secondary sensors, right? And having to run wires really, really delays it. So this is something you have moved into, wireless sensing. Tell us a little bit about that. Where are we with it? What's there and what's not quite there?
Well, the predominant number of sensors today are wired sensors. People are physically attaching them. Temperature, pressure, strain, voltage, current. RF is wireless. It's over the air. So 5G is a cool one because a lot of the testing is over the air. There's an antenna emitting something or you're transmitting. There's not a physical hookup to the sensor. So that technology is evolving. We're on that cutting edge, working with some of the early adopters in that. On the wireless sensor side for vibration and strain, we are just announcing actually in the next day a wireless sensor. This I sort of call it like a really thin but long cylindrical hockey puck. It's about that big. It's about the silver dollar size and maybe a stack of about 20 of them. For those who remember silver dollars, and I have a few Kennedy half dollars and silver dollars. So what's cool with that? You mentioned it, and you guys I know work in this area. The sensing and the high-speed data that you collect off vibration. That's at a different speed than temperature. So one thing is the speed. And then you can do a lot of mathematics to it to figure out, are things stable? Am I seeing different frequencies that I don't expect to see? Am I looking at it with database of signatures or data analytics? But another hidden cost is the wiring. And you actually have to put this device somewhere in a harsher environment. And you'd rather not run cable back out. So it really simplifies if you can give a high integrity connection, wireless connection, BLE, Bluetooth, lower power, then you can get the data from that thing, stream it, and not have to deal with the wiring. And I think we worked on a collaboration together with Ian.
We did, yeah.
And a common customer that you guys introduced us to. And we also have a few others, double handfuls of others, that were already pre-working with lead users in this area. And they're already also using this wireless little puck. I don't know if it's lick and stick, it's a little bit heavy, so
you don't want to lick it.
But it has some interesting geometry changes. But yeah, you can set it and forget it.
Is that a new area for you to go into, wireless sensing?
Absolutely.
I mean, your CompactRIO is all about connecting it and getting data and so forth, right? And so this is almost like a new generation for you.
It is. It's a new generation, but it's also an extension because we're hooking up to the same sensors. This is a new class of sensors that's wireless. So we have a data aggregator version and a one that goes straight into CompactRIO, as you said. That is a new area because there's probably new capabilities that we haven't even thought of before that now we would have access to. And that's exciting for us. So it'll open up some new opportunities. I think with yourselves and with others, people might want to deploy 1,000 of these at a time throughout an entire farm, whether it's an oil farm, whether it's a big plant. These are very affordable items with newer battery technology, lower power. It's all about power. If I don't think the iPhone and the Galaxy, Samsung notebook Galaxy would be successful without good battery technology. Nobody wants a device with such a thick battery attached. As soon as the battery got reasonable, we all started carrying these things around and maybe paying $1,000 for each. The sensors are like that. The battery technology has evolved. We're able to do things in 2019. We actually thought about them in 2001, 2004, but couldn't make it in that geometry.
It's all about the power that it consumes and how long can it run. Because eventually the swapping of the batteries becomes a logistical problem too, right?
Yeah, if you're in a nuclear plant and you're doing a monitoring application, To go into that plant is very expensive. If you're an oil refinery somewhere in sub-Saharan Africa, to get there is a lot of work. So battery power is pretty key, and we have some very good battery power specs on that. And then the other key is having software that makes it easy to take that data and do some cool math to it. Use the cloud as we do to really add value to the data, because the data is just data till you add some value to it through your intelligence, domain experience, decision making.
You talk about the cloud.
Yeah.
I'm curious,
Yeah.
what has the transition to the cloud for many people meant for National Instruments overall?
Yeah, we were talking about it after you and I spoke this morning. Somebody was up there talking about the cloud. I think we had a different presentation, and I've heard this the extreme. Why don't you put everything in the cloud? Can't you just put all the sensing in the cloud? And we think, wow, that might be a simplistic view of the world. And one thing you can do is look at the different levels of abstraction. You got the lick and stick sensor. You're streaming data back. You've got drivers talking to that thing. Then you've got raw data. Now you can engage the cloud. You can send the data to the cloud. But if you want to do some real-time decision making, you might want to keep the data local to close the loop locally. So for us, it's to better articulate the different levels of where the drivers and the data sit, and then what decisions you want made as a customer or as a partner, and where you want them made. Do you really want that decision made on a cloud? Or do you want it made on the local machine? Or do you actually want it made down in hardware? Do you want it made inside the node itself? Because you may want something that has more deterministic real time, that you may want to shut something off immediately based on some vibration or some temperature signal.
Yeah, the thing that always comes up for me as an example around this is this question of video processing, right? Because even when we talk about vibration, the data is manageable. Even
Yes.
raw data is sort of
Reasonably manageable.
reasonably
Still
manageable.
hard, but manageable.
Yeah.
Video is another
And
ballgame.
you're right, I might not send all that data to the cloud. It might
Yeah.
be a really waste of bandwidth,
Yeah.
even though it's getting lower and lower in cost. But when it gets to video, it's a bit of a different story, right? So when I think of video, this is when I start thinking of edge processing more. What has edge processing meant to you?
Yeah, and
Or what does it mean to you today?
well, we are big fans of edge processing because the more measurements you can do.
Well, aren't you edge actually per definition in a way?
So we're measurements at the edge. So
Exactly.
we like living on the edge, the measurements in the edge, and then you bring up a really cool app. We talk about cars. They're probably one of the primary now consumers of. You've got video, you've got audio, you've got radar, you've got other sensors. Vehicle sensors for blind spot detection. You've got LiDAR, which is a bit of a fight in the industry on who's going to win. But video still is a approach that works. And the more processing you can do down on the edge, you can be more intelligent in decisions you send back. And also, you can take that vision information, close the loop very quickly at a car. So you see something, you can take immediate action for the driver to assist them on what to do. We're a big leader on measurements at the edge, and then the software around doing that. Not all measurements need to stay at the edge, though. They can be streamed back up. You might do a car ride and test out all the systems of the car. So you want to collect all that data, stream it back to some server. You don't really want to do any closing the loop on the data. And that's a pretty cool thing because you can simulate drives in the city, you can simulate them on different roads and different geographies, up hills, down hills, with two cars trying to compete and maybe interact with some intelligent traffic sign at the same time. All kinds of complicated scenarios.
Have you been picked up by an autonomous vehicle yet?
I have not. Have you?
Yeah.
Oh, yeah. Where? In San Francisco?
I was in Vegas at a conference,
Oh,
and
yeah.
I walked out back one of the hotels, and I call a lift, and it says, "Oops, It said, "You're gonna get picked up by an autonomous vehicle. Is that okay with you?" And I'm like, "Oh my God, yes! So the fastest yes I've ever pressed." And so I walked out, and I got picked up by an autonomous car, and it was really fascinating. So
Yeah.
first of all, I was like all excited, right?
So
it was a
there
really
driver?
nice car.
Was there a driver in there?
There was a driver and there was a person sitting on the passenger seat. Because what ends up happening is the driver needs to be. So they drove off
Yeah.
the lot
Yeah.
on private property.
Yeah.
They weren't allowed to autonomously drive. Once they hit the street,
They're open.
then he said, I let go. So he needed to drive off the hotel property. So that was kind of a disappointment to start
What
with.
drives in Vegas stays in Vegas, so that's good for you.
Yes, yeah. And
And
then they had
how
a person
long-
sitting on the passenger seat, and the whole
Just to make
purpose
you feel better?
to talk to me.
Yeah.
Seriously,
How,
to answer
long
my
was
questions.
how long was the ride?
It was 10 minutes. I went from one
And it was
side of the strip to
Lyft
the
or
other.
Uber?
It was Lyft.
Good for you. I haven't.
And I wasn't allowed to take pictures. I wasn't allowed to tweet about it. I just, now I talk about it.
And you
but,
just asked for a generic Lyft. You didn't.
Just Lyft.
I'm a big fan of Uber, Lyft, all the rideshare companies. I have not made the switch to an electric vehicle or autonomous vehicle. I like some of the technology in the cars, and I have 2 young kids, sort of young, 22 and 18. I had to get them cars.
They're
recently.
both driving, probably.
But I bought them. I fixed a price. I said whatever I can buy for 10 grand. So when used cars, electric vehicles, get to 10 grand, I'm all in. I'm gonna buy them. And right now I just bought cars, so they'll probably last 5 or 10 years. But I think my next
So you
cars
don't
will be
want
electric.
an autopilot in your car?
I do. I'll take it. I have some simpler ones, but my next car will probably be one of them. But I just bought a car. We were overseas for a few years. Got back. We just happened to buy 4 cars for 4 people. I'm not a big fan of buying cars, but they needed them. So now we got 4 people, 4 cars, 4 drivers, and these cars run forever. So I probably gotta age them out over 10 years. They tend to not fail.
So as my last question, I want to switch topics totally altogether.
Go ahead.
You have a really interesting background, having lived both in Asia and run businesses in Asia, and lived in Europe and
Yeah.
run businesses over there. Contrasts, differences, things you really like, things you thought were very different.
I'll give you a work one, and I'll give you some personal ones, and these are opinions,
Love
so feel free.
Absolutely.
Don't edit them, but take them under advisement. So I found that for us, we make software for scientists and engineers. And I found that scientists and engineers everywhere in the world are equally cynical. They have to see to believe. Once you show it to them once and they get trust in what you've offered, they come back. And we tend to focus on the 20% that's unique to that German engineer versus Chinese engineer, but they're all equally cynical, frankly. And that has helped me because they're more similar than different. I would say that's the biggest thing I walked away with, is that scientists and engineers, mathematicians, equally cynical. But once you get their trust, you have a good customer base and loyalty and repeat customers. On a personal side, I'd say, man, the differences are there. I lived in Japan, and I spent a lot of time in France. To me, they're interested in design, shape, form, the aesthetics, not only the engineering. I think, to me, the Chinese have some of the traits of Americans: business-oriented, friendly, outgoing, friends of capitalism. I think the German engineers are really, really good. They're very into the technology, very dependable. Those are, of course, stereotypes, but they're all good stereotypes for me. So my wife is Australian. Our kids are born in Austin. We grew up in India, but I grew up in Boston. So we have a little bit of
diversity.
We have a little bit of rope you can give us to have some opinions, but we've liked all the places we've lived and always look at the positive. Americans have a lot of optimism, and we have a lot of natural resources in the country, so I love living here.
You just enlightened me on something that
Yeah.
I've always wondered.
Go ahead.
Someone said to me once, trust is not something you have to earn, trust is something you can freely give.
That's right.
And it was like, whoa. And I've used this since with people, particularly engineers. And I've had a guy sit there and tell me, oh my God, that gives me stomach cramps when you say that. But now I know, I grew up as an engineer. This is why this whole trust earning thing and versus trust giving is a big deal for me.
I've never met an engineer who said, I implicitly starting with trust in mind. They need to have a reputation, awareness of what they're working with. You look at how they buy and the homework they do. And
have you tried it on?
What's that? The
trust giving versus earning?
Oh, I don't know. I give trust for certain things, but I'm not an early adopter of technology. I build products for early adopters. I love them. I'm more of a later adopter, a pragmatist on technology. And if you look at the kind of cars I drive, and you look at the kind of TV I've got, and you look at the decisions I make, I'm a little more of a pragmatist, but generally optimistic, generally not pessimistic. But trust is maybe the next level. So I've met the same people you have who give trust to start.
I've tried it. It works for me most of the time, and I didn't quite see our conversation go there, but I really appreciate it. Thanks so much for taking the time.
Thank you very much.
It was good sitting with you
That's
and
great.
chatting.
Thank you,
and
Robert.
with that, we've come to the end of our coffee chat today. If you liked what you saw, please use that button up there to subscribe. And if you missed any past shows or part of this show, please check us out on YouTube. And with that, have a great day.